An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of a circle. So if we look at our picture to the right, angle ABC, the angle here, is our inscribed angle within this circle. An intercepted arc is an arc that lies between two lines, rays, or segments if the endpoints of a chord or arc lie on the sides of an inscribed angle, then the chord or arc is said to subtend the angle. Some theorems in this concept include: the measure of an inscribed angle is 1/2 the measure of its intercepted arc. The measure of angle ADB, which is this angle here, is equal to 1/2 of the arc A to B. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Angle ADB, and let me use a different color, angle ACB, they both intercept this arc AB here. So the two angles are congruent. Another theorem states a polygon is an inscribed polygon when all its vertices lie on a circle. The circle that contains the vertices is a circumscribed circle. The next theorem states that if a right triangle is inscribed in a circle, then the hypotenuse of the triangle is a diameter of the circle. If one side of an inscribed triangle is a diameter of a circle, then the triangle is a right triangle. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary and we know that the word supplementary means that they add up to 180 degrees. Name two pair of congruent angles. So here we need to see which two angles share an intercepted arc. We can see that angle ABD and angle ACD both share the intercepted arc of AD. So we can say that angle B is congruent to angle C. It says to name two pairs. So if we look at this upside down now, we can say that angle BAC and angle BDC both intercept the arc BC. So that means that angle A and angle D must be congruent as well. So that can be our second pair. Angle A is congruent to angle D. Now we have to name their intercepted arc. We know the intercepted arc of angle A and D is BC, and the intercepted arc for angles B and angle C was AD. Find the measure of angle A. So we need to find this measure here. if we look back at our definitions or our theorems, it says that the measure of ADB is equal to 1/2 of the arc. So if we go back to our question, that means that angle A is equal to half of arc BC. And 1/2 of 84 is equal to 42 degrees. So angle A is equal to 42 degrees. Last two questions on this page. Find the measure of arc EF. So if we need to find this arc, we have our angle is 51. So instead of multiplying by 1/2, we need to multiply by 2 because we need to do the opposite of what we did in number 3. So that means that 1/2 of EF must be equal to our 51 degrees. So EF is equal to 2 times 51, which is 102 degrees. So off to the side, we can say arc EF equals 102 degrees. The last question on this page asks us to find the measure of angle H. So this angle here, that angle also intercepts our arc of EF. Therefore, it must be congruent to angle G. So angle H also has to be 51 degrees. Find the value of the variable. So we need to find x. The angle has to be 1/2 of the arc. So 1/2 of 74 is going to equal x. So this gives us that x is equal to 37 degrees. Number 2 has multiple parts to it. If we look at angle A, we need to find this angle here. Because we know that CB is a diameter, because it cuts through the middle of the circle at point N, and it also has endpoints on the circle. That means that our triangle CAB must be a right triangle. So our angle A must be our 90-degree angle. Another way that you can prove this is our diameter CB can act as your intercepted arc of angle A, and that arc has to be 1/2 of the arc is equal to your angle A. And since the arc is a straight line, it is 180 degrees. And we know that 1/2 of 180 is 90 degrees. So that means the angle A must be 90 degrees. Angle C, we know that all of the angles in a triangle add up to 180 degrees. So we need 90, which is our angle A, plus 28, which is our angle B, plus angle C must be equal to 180 degrees. If you do the math on that, you will get that angle C is equal to 62 degrees. So we can go ahead and label that on our circle. Now we need the length of BC. Since we have a right triangle, we can use Pythagorean theorem. We have the two other side lengths of 3.9 and 7.3. So since BC is our hypotenuse, it's going to be our C in our Pythagorean theorem. So we're going to have 7.3 squared plus 3.9 squared equals c squared. This gives you c squared equals 68.5. Then we need to take the square root of both sides. That gives you c is equal to 8.28. So BC is 8.28. And we can label this on here. 8.28. Okay, number 4 wants us to find the measure of arc AC. So we need to find, let's use pink for this one. We need to find this arc AC. Our angle that corresponds to this arc is this angle here, which is given to us as 28 degrees. So our equation is 1/2 of the arc AC is equal to that 28 degrees. So in order to find arc AC, we need to do 28 times 2, which gives us 56 degrees. So arc AC is 56 degrees. And the last one is wanting us to find arc AB. So we need to find this arc here. And our angle that corresponds to that is going to be ACB, which we found earlier is 62 degrees. So again, we're going to set up this little equation as 1/2 of the arc AB is equal to 62 degrees. So to find AB, we need to multiply 62 by 2, which gives us arc AB is equal to 124 degrees. Wants us to find the value of each variable. So I'm going to begin with n. Earlier we stated that, where is it? This theorem states that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary, meaning that they add up to 180 degrees. So in this problem, we do have a quadrilateral because it has 4 sides. So that means that the opposite angles must add up to 180 degrees. So 100 plus n must equal 180 degrees. So that means that n must be 80 degrees. And our other variable is m. So m plus 65 must equal 180 degrees. If you can't do that one in your head, then you can always subtract 65 from both sides, giving us that m must be equal to 115 degrees. Number 4 is wanting us to find the measure of arc CD. So they labeled it X for us here. So the first thing that we need to do is know that our entire circle must add up to 360 degrees. Okay? So if we're trying to find this X here, we know that this is 2 X's, this is some unknown, and this is some unknown. If we can find all of those, then if we add them all together, they must equal 360 degrees. So if we can find our 2 question marks, then we can make an equation by adding them all together and setting them equal to 360 to solve for X. So let's try to find our arc BC first. So if we look at arc BC, we can see that angle BAC is 87 degrees. And so that means that arc BC must be 2 times 87 degrees, which gives us that arc BC is 174 degrees. Okay, and the other unknown that we needed to find was AD, this one here. We know that this one now is 174 degrees. AD, our angle would be ACD. The intercepted arc of that angle would give us AD. So that means that AD is equal to 2 times that angle, which is 27 degrees. So the arc AD is 54 degrees. Now, using this information, we know that 174 plus x plus 54 plus our 2x must equal 360 degrees because that includes our entire circle. Now, if we combine our like terms, we get 228 plus 3x's equals 360. This gives us, I'm going to go over here so I have more room. This gives me, if I subtract 228 from both sides, 3x is equal to 132. Then my last step is to divide by 3. So this gives me that x is equal to 44 degrees. And our x is the arc that we were originally trying to find, which is CD. So to give our final answer, we can say that arc CD is equal to 44 degrees. Okay, next page. Another theorem, it states that an angle formed by a chord and a tangent that intersect on a circle is half the measure of the intercepted arc. Okay, so this is similar to the other one, but instead of two chords, it is a chord and a tangent. So an example of this is our chord AC and the tangent CZ. They form this angle, and that means that the angle X here in this situation is 1/2 of the arc ABC here. So a little bit different. So let's apply this to this first practice problem. It wants us to find the measure of angle 3. So it wants us to find this angle here. Using the previous theorem, we can state that the measure of angle 3 is equal to 1/2 of the arc, which in this case it gives us 242 degrees. So that means that the measure of angle 3 is equal to 121 degrees.